In a dry mountain stream, I found a mineral sample that immediately caught my attention. A heavy black material with a strange property. But what exactly are these black particles? A common mineral, a rare material, or something worth investigating? The first thing I noticed was its strong magnetic behavior. When I brought a magnet close to the soil, a large amount of black particles attached to it. This type of reaction is often seen in some heavy magnetic minerals. But the main question is, what material is causing this strong attraction? What do you think it is? Magnetite, another iron mineral, or something different? Now I want to examine this sample using a simple separation method. In nature, water can separate minerals based on their weight and density. That is why heavy minerals can sometimes accumulate in certain areas of rivers and mountain streams. These black particles behave differently because of their high density and magnetic properties. To prevent losing the magnetic material, I placed strong neodymium magnets inside the washing pan. Now let's see what remains after washing. If you found this sample, what would you test first? Magnetism, washing, or chemical tests? Why can washing this soil give us important information? Over millions of years, natural erosion breaks down rocks and allows rivers and streams to transport different mineral particles. Lighter materials are usually carried farther away by moving water, while heavier minerals can accumulate in specific areas, such as river bends, cracks in rocks, and dry stream beds. This is why geologists and mineral explorers use gravity separation methods to study heavy mineral deposits. What makes this sample interesting is the combination of two properties: high density and strong magnetic behavior. This means some parts of this soil may belong to heavy minerals that behave differently from normal soil particles. However, being magnetic does not automatically mean a mineral is valuable, because many iron-bearing minerals have magnetic properties. But this magnetic response is still an important clue for mineral identification. After removing the lighter materials, the remaining concentrated material becomes easier to study and analyze. Question: what do you think we will find in this heavy mineral concentrate? A common iron oxide, a rare mineral, or a combination of different minerals? After the first separation, I heat a small amount of this black powder. The goal is to observe how the materials mixed with the sample, such as quartz or other silicate minerals, react to heat. Sometimes heating can reveal hidden particles inside a mineral structure. But will this sample change after heating? Now it is time for a chemical test. One way to study minerals is to observe their behavior in different chemical environments. I will test this black powder in two separate solutions: hydrochloric acid and sulfuric acid. In hydrochloric acid, we can see an interesting change. The solution becomes slightly yellow. This may indicate that some metal compounds have entered the solution. But the important point is, most of the black particles remain unchanged. Now for another interesting test. Even while these particles are inside the acid, a neodymium magnet can still attract them from outside the beaker. This means the magnetic part of the sample has maintained its properties. In sulfuric acid, no major visible change appears. The black particles remain, and they still respond to the magnet. At this stage, we know this sample has strong magnetic properties, high density, and resistance to several chemical environments. But the main mystery remains. What exactly are these black particles? What is your guess? Magnetite, titanomagnetite, chromite, ilmenite, or another mineral? But to understand this powder, we need to look back at the original rock. This is the source rock where these black particles came from. The rock itself is also attracted by a magnet, especially in the darker areas. Under magnification, we can see quartz-like areas and shiny metallic crystals inside the rock. But what are these metallic crystals? At this stage, I cannot identify this mineral with complete certainty. However, based on the properties we observed, there are several possibilities. Magnetite, titanomagnetite, chromite, ilmenite, or another mineral combination? Now it is your turn. Which one do you think is closest to this sample? Share your ideas and experience in the comments. In the next video, I will continue investigating this mysterious mineral sample.